Hello everyone. So in this session, we are going to start new topic that is a Kubernetes. So let's understand what is a Kubernetes. But before going to understand Kubernetes, we need to focus on Docker architecture. Then we can easily understand why Kubernetes is required, why Kubernetes comes into the picture. So I hope everyone you are aware with Docker architecture. Using Docker, you can containerize application. So if you want to containerize, you can containerize application using Docker. So Docker is a software tool that helps to containerize your application. So when you want to containerize your application, so first you need to create one Docker file, and this Docker file actually contains the instruction to build an image. So from the Docker file, you can build an image. And once you build an image, then that image you can put in Docker Hub registry. This is a public registry where you can place your image, or you can run container using that image. So you can run multiple container using the same image. So suppose here there are 3 containers are running using that Docker image. So in Docker architecture, there are 3 main components that we have required: Docker file, Docker image, and Docker container. So Docker basically helps to containerize your application. Okay, if you want to containerize your application, you can use Docker. Using Docker, you can containerize your application. Then what is the use of Kubernetes? So let's understand what the problem we are facing and then how we can overcome this problem. Let's take one scenario. Okay, nowadays whatever application is developing, application basically developed based on microservice architecture. Okay, in case of microservice architecture, actually every part of the application acts as a separate service. So suppose when you are working in a project, in your project you can have multiple modules, and each module acts as a separate service, a separate project in case of microservice architecture. So let's take one scenario. Suppose we want to develop one e-commerce portal. So in e-commerce portal, we have one service, product listing service, by which we can list out the product. And we have order service, we have customer service, and we have payment service, and we have card service, and we have visit service. So product listing is the part of your e-commerce portal. But in case of microservice architecture, every service acts as a separate project. Earlier, we have followed the monolith architecture. In case of monolith architecture, application have multiple modules and we have combined all those modules under a single container. But in case of microservice architecture, each module acts as a separate service and each module can perform independent operation, and one service can communicate to each other also based on requirement. And you can check just like product listing service has own database, order service has own database, customer service has own database. So there are multiple services. So this means in one project you can have multiple projects, and each project acts as a separate service for your application. Now, in case of microservice based application, suppose as of now in this scenario, how many module you have? Suppose there are 6 modules. So it means how many container you need to create, how many application you need to containerize. So you need to containerize each service. So you need to run each service into a separate container. So at least 6 container we have required to run your product listing service, order service, customer service, and so on. And you can check it. Each service is connected with own database. So database also required to run in a container, suppose. So there are 6 container required for database and there are 6 container required for your services. And one project can have more than multiple services, 100 of services, suppose 1,000 of services. Okay, so let's hear what we need to do. We need to containerize each application, each service we need to containerize. So here you can check here, we have created one container for product listing service. Now product listing service running inside a container and similar for other services also. So in this case, you have only 6 services, but in real time, you can have suppose 1,000 of services in a project and you can have, yes or no, multiple services. So for each services, yes or no, what you need to do? You need to create one container. Okay, so here you can check this scenario. There are 6 services, at least 6 containers required. But suppose tomorrow your application is growing, when your application is growing, more traffic is coming in your application. So then you need to scale up your application. It means you need to run your application in multiple containers. So there might be chance one application running in 10 or more containers. Suppose more request is coming, more network traffic is coming. So you need to run same application in multiple container. So you can think, suppose there are 10 container we have required for product listing service. For each service, 10 container required. We want to run each service in around 10 container. So around 60 container you have required for your running application. And sometimes actually what you need to do, sometimes you require to scale down. This means sometimes suppose traffic is not more. So 10 containers is not required for running product listing service. You require suppose 2 or 3 containers is sufficient to handling the incoming request. Then what we can do? Then we can remove those unused containers. Okay, after containerize the application in real-time scenario, there is a very big challenge how you can manage those containers actually. Managing container is one big challenge. Managing container means just like sometimes we need to add on more container, sometimes we need to remove the container based on demand, based on traffic. And sometimes suppose what happens, suppose any server, yeah, any container is not responding, is not working. So we need to replace that container with other container. So these are activity how you can perform. You need to perform this activity. If you are performing this activity manually, that is a very difficult challenge. Because if you are performing this activity manually, you can't handle properly. Okay, so after containerize your application, you need to manage those containers. So to manage those containers, Kubernetes comes into the picture. So here, why Kubernetes comes? Kubernetes comes into the picture to manage those containers. So using Kubernetes, we can manage containers, we can manage containerized application, we can manage containers. Using Docker, you can containerize the application. But once you containerize the application, you need to manage those containers. So for managing those containers, Kubernetes comes into the picture. So understand Docker and Kubernetes. Docker basically helps to containerize application. And now if you want to manage those containers, managing container means guys, just like adding new container, removing the existing container, yeah, replacing not working container with working container. So these are management, yes or no, you have required to perform. So you can automate this management tasks using Kubernetes. So Kubernetes is a, we can say, orchestration platform. So what means of orchestration? Orchestration means management. So we can manage those containers using Kubernetes. So let's understand, yes or no, what is a Kubernetes? What is a Kubernetes? So what is a Kubernetes? So Kubernetes also known as K8s. Why we are calling K8s? In short form, we can call it K8s. Because between K and S, there are 8 characters available. There are 8 characters each available. So Kubernetes is an open source, we can say open source orchestration, orchestration orchestration platform. Orchestration means management. So Kubernetes basically Kubernetes used to manage containers. You can manage the container using Kubernetes. So if you want to manage those containers, you can manage those containers using Kubernetes. So Kubernetes basically developed by Google, yes, no, developed in Google, and later on it will denoted to CNF, and now that it is a denoted to CNCF organization. So Kubernetes is a framework, we can say. So Kubernetes provides provide a framework for managing the complex tasks, for complex tasks of deploying. You can deploy, you can use scaling and operating applications in container. So Kubernetes basically, yes, no, is a framework for managing complex tasks like deploying, scaling, and operating application in containers. So you can use Kubernetes for managing container. So Kubernetes basically helps to manage your container. So what is the advantage of Kubernetes? We can say if you are using Kubernetes, so what is the advantages of Kubernetes? We can say first advantage, Kubernetes container orchestration. So Kubernetes helps to manage those containers. So container orchestration. Okay, understand the difference between Docker and Kubernetes. Docker helps to containerize the application, and Kubernetes helps to manage those containers. So you can manage those containers, and Kubernetes helps to scalability. Scalability means as per your demand, yes, no, you can you can manage those containers, and you can add on and you can remove. You can scale up, you can add additional container in the existing infrastructure, or you can scale down. This means you can remove the existing container from the infrastructure. Scalability also will taken care by the Kubernetes. And one more advantage of Kubernetes, self-healing. Self-healing means suppose if any container is not working, is not responding, then automatic it will replace unused container with healthy container. So it will take care automatic. Next advantage, load balancing. And now most advantages on load balancing also. So whenever customer are sending the request, customer are sending the request, the application load will be distributed among the container. So suppose your application is running multiple container. If you want to distribute the load, yes, no. So whenever customer, suppose you can think here, suppose product listing is running in suppose 10 container. So whenever any client make a request to access product listing services, so now request needs to be distributed, traffic needs to distributed among container. So now you have not need to take care. Who will take care? Kubernetes automatic will take care. Kubernetes will take care. What will take care? Kubernetes will take care load balancing also. So load balancing means distributing the traffic. So we can distribute the traffic also. So these are advantage of Kubernetes. So I hope it's clear what is a Kubernetes, why Kubernetes comes. Kubernetes comes into the picture for orchestration purpose. It means for container management, for scalability, for self-healing, and for load balancing. If you are using Kubernetes, so no need to manage those container manually. No need to scale up and scale down those container manually. Automatic, it will scale up and scale down the container based on demand. Self-healing, this means suppose if any container is not responding, not working, automatic it will replace that container with new one container. No need to take care manually. Load balancing, suppose your application is containerized application and your application running into multiple container. Now Kubernetes helps to take care to distribute the traffic also. Load balancing also it will take care. So that is a Kubernetes. So in simple term, we can say Kubernetes basically used to manage those containers. So using Docker, you can containerize the application, and for managing those containers, we are using Kubernetes. I hope it's clear. Thank you.